Chapter 10, Motion and Measurement of Distances. How do you come to school? Do you use the same mode of transport as liar classmates? Which mode of transport is the most common? How do you decide which mode of transport to take to travel to different places? You could take a bus, go on foot, or by car depending upon the distance between your house and the destination. Would you travel by train to go to a far-off place like France? Depending upon the distance one has to travel, one decides the means of transport. You can see different vehicles on the road such as cars, scooters, motorbikes, buses, trucks, bicycles and rickshaws, which people use to move from one place to another. The act of moving from one place to another is called motion. People walking, animals moving, movement of automobiles and flying of kites, birds and aeroplanes are examples of motion. Story of transport. Long ago, people did not have any means of transport. They used to walk and carry load on their back or head. They also used animals like horses, bullocks, donkeys, mules, camels and elephants. For transport in earlier times, moving across water was difficult. People discovered that they could use wooden planks for this purpose. Later on, people learned to stick together different pieces of wood and give shapes of boats. Invention of the wheel brought a revolution in the modes of transport. Animals were used to pull vehicles such as bullock carts and tongas that move on wheels. Vehicles that moved on wheels made traveling from one place to another more comfortable and faster. All vehicles used today, such as bicycles, motorcycles, scooters, cars, trucks, buses, and trains, move on wheels. Until the beginning of the 19th century, people still depended on animals, boats, and ships to transport them from place to place. The invention of steam engine introduced the railroad transport. Railroads were made to run carriages and wagons driven by steam engine. Later came automobiles such as motor cars, trucks and buses. Motorized boats and ships were used as means of transport on water. Aeroplanes were developed in early years of 1900, which made traveling faster. In the 20th century, electric trains, monorail, supersonics, and spacecrafts were developed. Figure shows some of the different modes of transport. Place them in the correct order from the earliest modes of transport to the most recent. Are there any of the early modes of transport that are not in use today? How wide is this desk? How did people know how far they have traveled? How will you know whether you can walk all the way to your school or whether you will need to take a bus or a rickshaw to reach your school? When you need to purchase something, is it possible for you to walk to the market? How will you know the answers to these questions? It is often important to know how far a place is so that we can have an idea how we are going to reach that place. Walk, take a bus or a train, a ship, an aeroplane, or even a spacecraft. Sometimes there are objects whose length or width we need to know. In Priya and Para's classroom, there are large desks which are to be shared by two students. Priya and Paras share one desk, but frequently end up objecting that the other is using a larger share of the desk. On the teacher's suggestion, they decided to measure the length of the desk, make a mark exactly in the middle of it, and draw a line to separate the two halves of the desk. Both Priya and Paras are very fond of playing gilli danda with their friends. Paras brought a set of gilli and danda with him. Here is how they tried to measure the length of the desk using the danda and the gilli. The desk seems to be having a length equal to 2 and a lengths and 2 lengths of the gilli. Drawing a line in the middle of the desk leaves each of them happy with a half of the desk equal to a danda and a gilli in length. After a few days, the marked line gets wiped out. Paras now has a new set of gilli and danda as he lost his old one. Here is how the length of the desk seems to measure using the gilli and danda. What would you suggest Priya and Paras do to measure the length of the whole desk? Can they use a cricket wicket and bales to measure the length, or do you think that this might create a similar problem? One thing they could do is to take a small length of string and mark 2 points on it. This will be a string length. They can measure the width of the desk in string lengths. How can they use the string to measure distances less than the length of a string? They can fold the string and mark it into 24 and string lengths. Now perhaps Priya and Paras can measure the exact length of the desk using the string. You would say that they should use the scale in their geometry box and solve their problem. Yes, of course. Paras has been reading about the way people used to measure distances before such standard scales were made, and he has been trying to follow different methods of measuring distances, measuring the length of the desk with string lengths. Many a times you need to measure lengths and distances. A tailor needs to know the length of the cloth to stitch a dress for you. such as shirt, pant, kurta, pajama, and coat. A carpenter needs to measure the length, height, and width in order to make furniture, such as chair, table, sofa, and cupboard. The farmer needs to know the length and breadth or the area of his land to know how much seed he can sow and how much water would be needed for his crops. Suppose you are asked how tall you are. You want to tell the length of a straight line from the top of your head to the heel of your feet. How long is this room? How wide is this desk? How far is it from Delhi to Lucknow? How far away is the moon from the earth? All these questions have one thing in common. They all concern distance between two places. The two places may be close enough, like the two ends of a table, or they may be far apart, like Jammu and Kanyakumari. Let us do a few measurements to see what exactly we need to do when we measure distances or lengths. Some measurements: in order to measure any particular quantity, you should know the unit of measurement and the number of units that particular quantity measures. In ancient times, people used handspan, cubit, arm length, and footstep as different units of measurement of length and distance. Handspan: it is the length between the tip of the thumb and the little finger when stretched. Cubit: it is the length between the tip of the middle finger and the elbow. Arm length: it is the length between the shoulder and the middle finger. Footstep: it is the length between the great toe and the heel of the foot. Handspan, cubit, arm length, and footstep differ from person to person. This is because the hand, arm, and foot length of all humans is not the same. Hence, these units of measurement lack precision. Let us measure length in handspan, cubit, arm length, and footstep in activities 1 and 2 and compare your results with your classmates' results. You will observe that the variations in results are similar, as observed in activity 1. This is because of the reason explained in activity 1. All the measurements recorded in the table in both the activities were not equal. There was a slight difference in sizes of body parts of different people. This led to confusion in measurements. Therefore, there was a need for some standard units of measurement that does not change from person to person. Standard units of measurements. In ancient India, small length measurements used were an angle finger or a muddy fist. Even today, we can see flower sellers using their forearm as a unit of length for garlands in many towns of India. Many such body parts continue to be in use as unit of length when convenient. However, everyone's body parts could be of slightly different sizes. This must have caused confusion in measurement. In 1790, the French created a standard unit of measurement called the metric system. Different standard units of measurement were created at different places. For the sake of uniformity, scientists all over the world have accepted a set of standard units of measurements. This standard system of unit is known as the International System of Units, ICSI units. The SI unit for length is meter. Sometimes you need to measure very long lengths and sometimes very short ones. Therefore, depending upon the need, different simple multiples and sub-multiples of unit of length, i.e. meter, are used. The length or breadth of a room is measured in meters. The distance between two places, i.e. towns and cities, is measured in kilometers. The length of a notebook is measured in centimeters. You will observe that the variations in results are similar as observed in activity 1. This is because of the reason explained in activity 1. All the measurements recorded in the table in both the activities were not equal. There was a slight difference in sizes of body parts of different people. This led to confusion in measurements. Therefore, there was a need for some standard units of measurement that does not change from person to person. Standard units of measurements in ancient India, small length measurements used were an angle finger or a muddy fist. Even today, we can see flower sellers using their forearm as a unit of length for garlands in many towns of India. Many such body parts continue to be in use as unit of length when convenient. However, everyone's body parts could be of slightly different sizes. This must have caused confusion in measurement. In 1790, the French created a standard unit of measurement called the metric system. Different standard units of measurement were created at different places. For the sake of uniformity, scientists all over the world have accepted a set of standard units of measurements. This standard system of unit is known as the International System of Units, ICSI units. The SI unit for length is meter. Sometimes you need to measure very long lengths and sometimes very short ones. Therefore, depending upon the need, different simple multiples and sub-multiples of unit of length, i.e. meter, are used. The length or breadth of a room is measured in meters. The distance between two places, i.e. towns and cities, is measured in kilometers. The length of a notebook is measured in centimeters. The thickness of a wire is measured in millimeters. The relation between these simple multiples and submultiples is shown in the given table. Now we can repeat all our measurement activities using a standard scale and measure in cell units. Before we do that, we do need to know the correct way of measuring lengths and distance. Correct measurement of length in our daily life. We use various types of measuring devices. Use a meter scale for measuring length. A tailor uses a tape, whereas a cloth merchant uses a meter rod. For measuring the length of an object, you must choose a suitable device. You cannot measure the girth of a tree or the size of your chest using a meter scale, for instance. Measuring tape is more suitable for this. For small measurements, such as the length of your pencil, you can use a 15 centimeters scale from your geometry box. For taking measurement of a length, the following steps are followed. 1. Place the meter scale along the length to be measured, parallel to its graduation, the markings on a scale as shown in figure on next page. 2. Make sure that its zero mark coincides with one of the ends of the length to be measured. 3. In some scales, the ends may be broken and you may not be able to see the zero mark clearly. In such cases, some other digit, say mark 1, can be taken as the initial reading. You must remember the digit taken and subtract it from the final reading at the other end to get an accurate measurement of the length. For example, in figure B, the initial reading is 1 centimeter and the reading at the final reading is 6 centimeters. Therefore, the length of the box is 6 cm, 1 cm, 5 centimeters. For taking measurements, correct position of the eye is also very important. The eye must be placed exactly vertically above the mark to be read. Measuring the length of a curved line. Can you measure the length of a curved line, say a curved electrical wire, like you measured the length of a geometry box? Certainly not. You will need a thread to measure the length of a curved line. Types of motion. The different types of motion around you can be categorized as follows. Linear or rectilinear motion. An object is said to be in linear or rectilinear motion if it moves from one position to another along a straight line in one direction only. Examples: an automobile, bicycle, car, bus, scooter, etc. moving on a straight road, a battalion moving in a parade, an apple falling from a tree, a striker hitting a coin on a carom board. You may have observed the motion of a vehicle on a straight road. March past of soldier in a parade, or the falling of a stone. What kind of motion is this? Sprinters in 100-meter race also move along a straight track. Can you think of more such examples from your surroundings? In all these examples, we see that the objects move along a straight line. This type of motion is called rectilinear motion. Circular motion. An object is said to be in circular motion when it moves on its own axis or around a fixed center. Examples: moving fan and windmill. Movement of the Earth, rotation on its axis and around the Sun, revolution. Movement of a spinning top's wings like merry-go-round. Take a stone, tie a thread to it and whirl it with your hand. Observe the motion of the stone. We see that stone moves along a circular path. In this motion, the distance of the stone from your hand remains the same. This type of motion is called circular motion. The motion of a point marked on the blade of an electric fan or the hands of a clock are examples of circular motion. The electric fan or the clock by themselves are not moving from one place to another, but the blades of the fan rotate, and so do the hands of a clock. If we mark a point anywhere on the blades of a fan or on the hands of a clock, the distance of this point from the center of the fan or the clock will remain the same as they rotate. Periodic motion. In some cases, an object repeats its motion after some time. The motion where an object repeats its motion after a fixed time interval is called periodic motion. Take the stone tied with a string that you used in activity 6. Now, hold the string in your hand and let the stone hang from it. This is a pendulum. Pull the stone to one side with the other hand and let it go. Now the pendulum is in motion. A branch of a tree moving to and fro, motion of a child on a swing, strings of a guitar, or the membrane of drums, tabla, being played, are all examples of periodic motion where an object or a part of it repeats its motion after a fixed interval of time. Have you observed closely the motion of a ball along the ground? Here the ball is rolling on the ground, rotating as well as moving forward along the ground. Thus, the ball undergoes a rectilinear motion as well as rotational motion. In many objects, more than one type of motion can be observed, i.e., combination of different types of motion. A few examples are given below. 1. An automobile moving on a straight road. The automobile moves in a linear motion and its wheels rotates in a circular motion. 2. Motion of a sewing machine. The needle of the sewing machine oscillates and its wheel rotates in a circular motion. 3. Motion of Earth. The Earth keeps on rotating on its axis as well as revolves around the Sun. Thus, there are two types of simultaneous circular motions for drawing water from the well. In a well, the pulley on which the rope runs has a circular motion and the bucket has a linear motion. We did many measurement activities and discussed some kinds of motion. We saw that motion is a change in the position of an object with time. The change in this position can be determined through distance measurements. This allows us to know how fast or slow a motion is. The movement of a snail on the ground, a butterfly flitting from flower to flower, a river flowing, an aeroplane flying, moon going around the earth, and blood flowing inside our bodies show that there is motion everywhere around us.